All right, this is a video about the lab 3. So lab 3 will probably, the due date will be extended. I'll make an announcement. I can't get too far behind on lab 4. I think we have 1 week in play, like a buffer week on getting all the labs done before the end of the semester. So I'll try to fit the due dates in that way. But I wanted to give some tips on the lab itself this time. Chapter 13 will be coming soon, notes on that. But I just want to give some hints on the lab itself. So that's what we're going to do. Here's the description of the lab. And the first thing I want to note is do make this look almost exactly like this. You can I was going to tell you not to get creative, but I got creative. So the way I got creative was I used the obelisks for division. It's not clear actually. It's not a plus sign. It's the obelisk is what it's called. The other division symbol instead of a slash. You can also use a slash if you want. And I use the radical. This is not a very good font for the radical because you can't see the top overhanging thing very clearly. It just looks like a check mark, but it's a radical symbol for square root. You can use just SQRT. You can do the colors. The colors should kind of match this. Notice the blue's a different blue. Also the style of the buttons. I don't know how you manage that style. I don't know if it's like a Macintosh thing or it's just some other setting of the buttons, whatever. This is Windows actually, isn't it? Anyway, it doesn't have to match exactly, but you do need to, in general, do the same number of buttons and do the same operations. That's what I want you to do. Match the color kind of thing. The way it's, these are red and these are red and this is red. Do try to match that. And again, match the functions. So this should be a square root. This should be a reciprocal or inverse, I think actually is what it is. Reciprocal's a little different. But in any case, this is the sign, etc. This also should be a read-only text box, which is what this appears to be. And just to give you a hint on that, it's the alignment is right alignment. That's how you get this kind of behavior right here, which you're used to with calculators, right? So I thought I had a calculator up already to compare to. So this is a real, well, I guess this is a real calculator too, but this is like a very well tested one, right? Because it's released with Windows. But you notice that as you type, they go. And don't worry about the comma. That's an idea. If you want to, as a matter of fact, if you want to implement that, I encourage it. It's not called for in the lab, but if you do, it'd be actually kind of neat. It'd be it didn't even occur to me because I'm so used to in programming world and not putting the commas, but it's not a bad idea. Okay, so yeah, so the GUI again, make it look like the same number of buttons, the same functions, read-only text box. Make that be the same at least. Okay, so let's talk about what you need to do. So you need to perform addition, subtraction, so all the things we just said. And the way you do it is, so just test this. 2 plus 3 equals, hold on. I already had stuff in here. 2 plus 3 equals 5, right? So that's that one. Just to test some other ones. Let me clear this first. 3 minus 3, 0. 6 minus 2 is 4. 6 divided by 3 is 2. You should also be able to do this kind of thing. Divided by 5, right? You would get fractional stuff. What have I not done? I multiplied? I can't remember. Square root would be, what's the square root of 16? It's 4. That's correct. The reciprocal of this, so if you do a 4, or the inverse of 4 is a quarter, right? 1 over 4. That's what that is, 1 over x, right? So those are all the operations. And then the next part of it, to perform, so if you do chain them together like this, 6 plus 3 is 9, minus 1 is 2. Wait, hold on. 6 plus 3 equals 9, minus 1 is 8. I don't know what I did there. I might need to reset in between. That might be what's going on. So 9 divided by 3 is 3, minus 1 is 2, and that kind of thing. Then if you do, like, say, 1, let's do that. 1 plus 1, you just keep adding 1, right? Or 3, 3 plus 1, 4, 5, well, plus 2, and so on, that sort of thing, divided by 2. So what you would expect. Of course, this goes on forever, because you can always subdivide something. All right, unless it's 0. Okay, so where are we at? So the previous operation equal, that's that second bullet point. Square root, I think I showed that one already. That's 9 square root, you know. And the inverse, we already did that. So yeah, the inverse of 3 is 1/3, or 0.3 repeating forever. Let's try this actually. 3 inverse times 3, what is that? It's 1. That's a hint for you. It's not exactly 1 in a calculator, but in real life, 0.33 repeating times 3 is 0.999 repeating, which is exactly, precisely, not any little bit above or below 1. It's exactly 1. We can have an argument about it later if you want, but it's a mathematical principle. It's just a 0.9 repeating forever, not in a calculator, again, because computers are finite machines, so the representation has to stop at some point. But in mathematics, 1/3 times 3 is 1, or 0.3 repeating, which is 1/3, is precisely equal to 1. Not even a little tiniest bit less. Anyway, we'll have that argument later. I'm sure some people are gonna not like it. There's always a few. Calculate the reciprocal. Yeah. So it's this part's just talking about. So yeah, in the negative, that's what that would look like. Times 2 would be -6, right? So make sure that works. The last digit entered. So back. Now here's the thing I notice about this. This is where you want to pay attention. I'm just kind of demonstrating how your calculator should work. So most of this is just like kind of set up and before we get into details about how you might do some things. And I'm not going to give you total details. I'm just going to try to give you hints about what I did. But the back, notice the back. Every time I hit back, this gets smaller. You have to use like a string builder. So what I do, let me just talk about this. The digits, every time I press a digit, followed by another digit, or followed by, period or whatever. And by the way, I don't think I've done this yet. You can only have one decimal point, right? And mine has more than one. I just realized it's going to happen. So if yours has that, it's okay. You should probably limit it somehow. That's another thing that everybody's, including mine's, not going to have everything probably accounted for, but that's something to think about. It just occurred to me just now. You can't have more than one period. But anyway, what this does is it builds a string. You just keep adding on to the string as you click more buttons until the point in time when you hit some operator. So if you hit a plus sign here, what that will do is convert that string into a decimal and feeds it to that your calculator class. Most of the stuff we've been doing is inside the form class so far, not the calculator itself. The calculator is an interface to do the math. You want to limit everything with the calculator to just doing the math stuff. You don't want to do any displays or parsing or anything in the calculator class. You just want to do math pretty much, and I'll show you how that works. But so what'll happen when you hit one of these plus signs, it goes into the operand 1, converts it to a decimal, which is operand 1 in your calculator class. Then also in your calculator class, you have this enumeration or enum of operators that you can do. It stores that operator. So if you do the plus sign, it's going to be the operator.add or whatever. That's what's going to be saved. And then later on, then you can proceed to type another string. So you're building another string, and as soon as you hit the equals or another operator, it goes into the operator 2. It goes into operand 2. And then you've already got the previous operation saved, the button that was clicked, because remember it was operator.add or whatever. So now it'll perform that math and give you the answer. So that's kind of the general way this works. So clear. You can decide on this. I haven't really decided totally myself. I think this. Let me check. So if I do 3 plus 1 and then hit clear and then do plus 1, I think it's still just going to be 1. Yeah, so it clears out the whole thing. It's kind of like the AC. I treated it like AC in a regular calculator if I'm remembering correctly. I'll let you guys decide how you want to implement that. I won't count it wrong either way, but say 6 plus 1, and then you're like, and then if you click, I don't see an all clear. Here's a, actually, I see, okay. You do a clear and then do 2 instead. Yeah, so it does kind of what I'm doing, the C here. It used to be calculators would have a clear entry and a clear, or an AC, I think all clear sometimes. But anyway, the clear entry would, like, if you typed, like, say, for instance, it's just clear, 23 plus 13, but you meant to type 12, you could do clear entry and type C. We don't have that, though. Okay, so that's enough about that. That's how the form works. The GUI part and the procedure you can see. And again, back, let me talk about the back. So what you'll notice about the back is every time I click it, it shrinks it from the right hand side. Until what? What should happen when you click back one more time now? It should be 0. Don't mess that up. When you get to the last digit, when there's only one left and you click back, you should not go back again. Because if you do, you'll go into the negative indices, which is not allowed, and you'll get a crash. You need to keep it from going to negative indices of your string, and just set it to 0. One other thing, and I won't actually count off if you don't do this. I just had to add this myself. If you say, for instance, 1.2 plus 1.8, you might get 3.0 here, depending on how you do it. I won't count off for that, but you could also just build in a little bit of logic that says, okay, if this is basically an integer, I'll just tell you, if I subtract the integer part from it and I get 0, is how I did it, then I know that it's just an integer, and I can cut off the 0.0 at the end. It's not a big deal. It's just not as pretty, because if you're used to the way calculators work, for instance, a real one here, 1.2 plus 1.8 is equal to what? 3, not 3.0. Though in computer programming, you do want to remember, usually, when you add two floating point numbers, you get a floating point number as an answer. So this is kind of going against, but this is kind of like everyday person, like what they do, they add two numbers to the fractional part, they get a whole number. That's the way they think of it, and they don't really think of the 0.0. So I guess that's the way why calculators do it that way. I don't know. But it cuts off I guess I would call it the trailing zeros as well as the leading zeros, right? If it's an integer. All right. Anything else? Did I do the sign part? I think I did, but just in case I missed it, -3 times 2 is equal to -6, so that should work. And I think I might need to be resetting to clear sometimes between operations. If you need to do that, that's fine too. I'm going to ask more of you than what I'm doing. Okay, so this is going to be a long-winded explanation. I don't want to cut this up into several different videos. I just want to go through the whole thing, so you may need to fast forward and go back and forth to see things that I talk about. But we're going to talk about the next part now. So I'll leave that running, because if I don't, as sure as I don't leave it running, I'll have to start it up again. So you need to create a class named calculator that implements the functions of a calculator. So design whatever methods and properties you need for this class. Now it's up to you, but you need to, I will say this, you must create a calculator class that uses principles of object-oriented programming, however you do it, which means you might not have precisely this stuff, but you need to have something kind of like it. And I'll talk about, I tried to make it match this exactly, even though I'm not sure I would do it this way either, but this is what you were given. And I'm like, well, I want them to know I want them to have the hints that I give them about how to fit as closely to this as possible. So again, you can create a class that is the calculator class that has different methods, maybe a little bit. You might not use this operator thing. But I would recommend doing it this way. It's not that hard I'm not saying it's not hard, it is kind of hard to do, but it's not hard to stick to this, any harder really to stick to this than it would be to do it in a different paradigm that you come up with. But you are allowed to do it I would say this, you need to have some fields, you need to have a constructor of some kind. It doesn't necessarily have to be empty constructor, but with no parameters, but it could be. I would say you need to have this property, probably. Yeah, technically speaking, you don't, but I recommend doing it just so you get experience with at least one property. And then you should have some methods for the math part, the operations that you have. If you wanted to add for like inverse and square root and stuff, that feel free to do that. But you can stick to this and it will be counted correctly, as correct. So with that being said, the current value is it's not auto implemented, this property. There's actually a current value behind it, and it's the property is read only. So you can't set the current value for the calculator through the current value property. This has to be arrived at using math, the current value. Operand 1 and operand 2, these are both decimals, and like I was saying before, you click a bunch of digits. Just listen closely to this if you need a refresher. I explained this before, but it's just a repetition now that you can see what we're talking about here. Click buttons that are numbers on your calculator, right? So 3, 2, so let me do it. So 6, 5, 8, etc. That's building a string. It's not operand 1 yet. This is a string. It's characters. It's not a number yet. But as soon as you click an operator key, like plus, it'll set this operator enumeration. We'll talk about enumeration here in a second. This is a big reason why I wanted to do this video, is because we haven't really talked about enumerations yet. It will set this to add when I click the add button. And it will set this operand 1, which is a number, to this string. And then you are ready. You need to reset your string somehow and start typing more digits, maybe a 0.2 in there. And then when you click another operator or equals, any operator really, it will set that second operand to operand 2. So it'll set the string to operand 2, and then it'll remember, because you saved it when you click the plus, you set this to add, so you know to do the add stuff. All right, your constructor, calculator, object with default values. So the operator field is none. The default for that enum is none. This will just return whenever you do current value. So calculator dot current value, it'll return the current value. By the way, you could use static. You could use a static class to do all this stuff. I didn't. I actually instantiate a calculator object. It's probably not necessarily it's a debate about whether you do it. It should be a static class, but you can either do static stuff if you want, or you can do, I do recommend doing it as a regular class to get you experience with that first. So anyway, default values. So, and then let's look at the class at this point. So this is what my class looks like. I've got everything folded up so you can't see it because I don't want to give everything away, but here's the structure of my class. So notice I have a decimal called current value. It's recommending for me to use an auto property, but I'm not going to. I guess I could do a read-only auto property, but that's fine. This is just a private instance variable. So this should be whatever the last operation result was. This is operand 1, operand 2. Remember, operand means, let me just type it real quick here, 2 plus 4. In a binary operation, 2 is operand 1. I would have actually rather have called this left operand and right operand, because that's kind of traditional, but that's not what they were named in the lab, so I went by the lab. So this is operand 1. This is the operator, the plus sign. It's performing the addition operation. And then you've got operand 2. So operands are the things that the operator operates on to perform the operation. That word, by the way, opus, magnum opus, great work. They're all opus, opera is the Latin for it. So a work and works, plural. So like something you work on, something you do is what an operation is. So a little bit of a etymology there. Let me shrink this up, by the way. This is running, so I have to probably wait till I stop it, but whatever. So this is what an enum looks like. This is an enumeration. Enumeration is a way to map a set of things to numbers, typically counting numbers. the natural numbers are in the real world are what you map to prove that something's countable. So the integers are countable, right? Because you could say the integer 0 maps to 1, the natural number 1, and then natural number 2 maps to -1, and natural number 3 maps to 1, and then and so on. You keep going back and forth around the negative and positive, and you can assign every integer to every natural number because they're both infinite, but they're countably infinite. And what that means is you can always have another natural number to assign a positive or a negative integer to. I don't know if that makes any sense, but it's number theory. But that's where all this comes from. Enumerate means you can count things. So the thing you're counting here is all the different kinds of operations you have. So I hope I got this right. Like I meant to check to make sure I had all the operations. So constants for add, subtract, multiply, divide, and none. So I do have those. And what they map to are actually, for an enumeration, if you don't specify, and you can do that by saying equals an integer, it will map to integers. These things map to integers, and the integers they map to are 0, 1, 2, 3, 4. I think you should be able to cast this to an integer, in parentheses operator.add, for instance, and it would show 0 as the answer. It's just a quick way. Why does this exist? This exists so you, as the programmer, have a mnemonic memory aid, right, to know what each thing is. Instead of remembering that 0 means add, you just say operator.add. Instead of remembering that subtract is 1, you can do operator.subtract. So it treats them still just like integers, but and I probably need to show an example of how they work, but this is the private enumeration. You could also, as an alternative, which is what I would normally do, except for this class, I think it kind of works elegantly to put it inside the calculator. So this is kind of enumeration is a special kind of class in a way. This is a member class that you define inside of another class. It's a class that contains a class, but it's a special kind of class called enumeration. You could create this, add this to your project as a separate file, and then refer to it that way. But I think it's better to include it as part of this calculator so you can show that it really is an integral part of the calculator. So these are all the operations you have. All right, so that's an enumeration. Here is the constructor. What does the constructor do? You just have to see what it does. See if I remember what it does. It creates a calculator object with default values. So default values for op is none. Default values for the decimals and stuff. I'm trying to remember what I have actually, but just create a calculator object. Current value will be whatever the value of this is, but it will only be, and I'll show this to you. It's just a read-only property, right? You return current value you get. I'll let you work out how to do the logic of these. But just know that when you click add, when you do the add, you're adding whatever the current value is for operand 2 to the operand 1. So remember, and for equals is a special, kind of flash there for you. It's a special case. I'm trying to remember. I'll tell you this. My equals with the argument, the decimal display value actually calls equals in it. Inside the body of equals with the argument, I call equals without the argument. So think about that and what that could mean. And then clear just sets everything back to what it was. So that's the class. So all the, here's what I'll tell you this. For these, you're going to get a lot of repetition, maybe here a little bit too, but you're going to get a lot of repeated code if you want to extract out into a separate method, because some of these things will always be the same. You'll always be setting operand 1, getting this current values display value or something like, I can't remember, operand 1's display value, whatever. You'll be repeating code. I didn't separate it out into a separate method because if you look at this definition, it doesn't have any separate private, I would call it a utility method, just to save me some repetition. So it's okay if you repeat, is what I'm trying to say. It's okay because these are actually not very long, and if you have repetition of code in these, it's okay. What else did I need to tell you about? So let me pause and look at the rest of my code and see what other tips I need to give you and how I can make it, give you some hints. So let me find the pause button. Oh, I can never find the pause. Have I been talking this whole time and not recording? Is that what's going on? Please tell me that's not what's going on. So yeah, it was recording that entire time. I just can't. Sometimes Screencast-O-Matic, you lose your interface. As a matter of fact, I don't see it right now, but I do see the pause. But anyway, so something else I don't remember because I made a couple of takes of this, and this is the longest take, so I'm not going to redo it. But something else I didn't point out is that when you do leading zeros, you shouldn't be able to do leading zeros. So figure out how you might need to do that. See how I keep clicking 0 doesn't add to, you don't have a bunch of zeros across the text box. And if I do 0, 1, it's just 1. So that's another thing to keep in mind. I think I did talk about the back already. If you back past the first digit, it should go to 0, right? So you have to do these little logic tricks in here. So that's the next hint I need to give you. And here's one I'll give you real quick. Let's see if I can pull it up. I'll pause, make sure I don't expose anything. Okay, so I think this is fair. Oh, by the way, on that last thing I said, I was thinking about it after I paused. I'm like, I could just mute the video, right? That's all I'll say about that. But anyway, so this is my form. So I gave you the outline of the calculator. I'll give you the outline of my form class. So this is what I've got. First thing is I have a calculator variable. Obviously inside of my, I'll just show this to you. I create an instance of that calculator here. Some things that I talked about design patterns before. If you use a static constructor or static, I'm trying to remember how all that works. The singleton, I had to look up that pattern, but that would have been a thing. You probably don't need more than one instance of a calculator. You just need one, right? So you could either have a static class entirely, or like the math class, for instance, or you could have a singleton built into your calculator. But yeah, we won't talk about that. That's getting confusing. But anyway, you can see what I do. I have a calculator variable, and I instantiate one whenever this form is brought into existence. So there's only one form in this project. Now, I have this Boolean called needs clear. I set it out equal to true. Here's the thing you want to think about. This has to do with my leading zeros. So needs clear means that I need to go back to, how did I put this? I need to clear out the string if this is true, otherwise I set it to false. So what that means is, for instance, when you start clicking digits, you set it to false until you get to a certain point when you set it back to true. It's a toggle. So I use these toggles are common for this kind of thing. Let me tell you another example of this. An example of this is, say you've got Notepad plus your own Notepad that you create, which is something you guys could do at this point. Especially after you have some little file IO. I can't remember if we haven't done file IO yet. But if you did, you could do a Notepad very easily. You just make a really big multi-line text box. Then you have what you call it maybe a dirty bit or a dirty indicator, which means that every time your text box changes, you set that the text box has been changed to true. Then if you try to exit, like clicking the X, that sets off the form closing event that triggers it. So then you would check your form closing event whether that little toggle's true. If it's true, then you prompt the person to save. If it's false, that means you haven't made any changes since the last time you made changes. So when you save, you set it to false, for instance, right? When you save your document, you set it back to false. And as soon as you start typing, it makes a text changed event happen in the big multi-line text box. That sets this toggle to true. And then, so you see what it's like a trigger. It's like a safeguard. It's keeping track whether something's changed or not. This is kind of how I use this. And you could do other things too. There's probably a more elegant way, but I use it to keep track of whether I need to do a leading zero or not. What else? I'll just tell you, I don't do anything in the form load. You can see that. You might. It's perfectly plausible that you might have something you want to do in your form load, but I just didn't choose to do it that way. So you can see I have two events. I have digit clicked event handler, and I have operator clicked event handler. And what that covers, and this is a big hint, I think, in my opinion, this is a big hint. Let me run this. That means that all these digits and maybe like, I think maybe the period and some other stuff. I can't remember which ones I picked, but definitely all the digits 0 through 9, right? Whenever you click one of these, it's handled by this event handler. So what does that tell you? That tells you you have a big switch in there that does something based on which digit you clicked. And then if you click one of the operators, definitely these, I think maybe the equal sign, maybe some of these, the back and the clear. No, actually clear, you can see clear back 0. I have a special case for 0, so it's not all the digits that are handled by this. 0 has its own event handler. The sign, I made one for the sign. I could have probably, I did this last because it was an afterthought. I probably could have folded it into one of these, but I didn't. The dot, though, that is a digit clicked. I consider that a digit. So there's really just this event handler, and then some of these special ones. So for the clear, that could have been maybe handled by one of these. But how does this work? So you just have to think about what you're going to do when you click a digit versus what happens when you click an operator. That's the main difference there. And then you have some of these special cases that you could maybe or may not fit into one of these up here, but I just chose to do them separately. But this is the main thing here. What happens when you click a digit? Remember, you build a string over time, and then when you click an operator, something different happens. You set what the operator is, you convert the current string to an operand, etc. So that's what you have to think about. And you don't have to do it this way. You could have an event handler for each different digit. I recommend learning how not to do that, because it makes your code really bloated and repetitive in a way that you don't need to do. You should realize that when you click any number, you're doing mostly the same thing. The only thing that's different is which sender you have. So each digit will be a different sender. Remember, the object that sends is the sender is the object that made the event happen. So if you click on button 7, for instance, BTN, you can call it BTN SEEVN is what I did. Then that the object that this is, when you click on the buttons BTN7 button, is BTN7. You just convert it to a button and you can get information from it. Like, for instance, I'll tell you how I did it. You could use the text property. I just actually used the tag. I think I used the tag property as a string. So you guys used the tag in the last lab, and it's kind of weird. This is because it is an object, but a string is an object. So if you look at my design, first of all, here's how you do this. You create the event handler first. And then whenever you click on a button, let's say I wanted to change to digits from operator on this one. You see they're all listed here, but it's got to stay operator because that's what it does. But as far as these buttons go, the digit buttons, notice if you look under the properties, that was events. The lightning bolt is events, right? And again, this is how you assign events. But under the properties, alphabetically, I have a text property. It just says 6 in there. That's what you see. You could use that. I guess I didn't use the tags on these. I just used the text property, apparently. So, okay. What did I use? I think on the operators, I did use the tag for some reason. I guess I didn't really need to, but you can see that I used the slash as the tag. That's how I know it's division, but then I use the obelisk for just cosmetically. I just used the letter X here. There's probably a better X you can use, but I used the asterisk for to indicate in my program that multiplication was chosen. Equals, I just used equal signs. Root, I used the word root. So you can do a switch on, what I did is a switch on strings, and the strings that I looked at were the tags. So I switched in the case where it was root, I did the square root. The case where it was inverse, I did the inverse, and so on. So I didn't need to do that for the clear. The clear and the back don't have information to transmit, really. You just do the logic for those functions because you know what the function is. But for these, since they all share one event handler, 1 through 9 share one event handler, you have to know which button is making the event happen. Same thing for these. All of these share one. I think they all share operator event handler click. So also, by the way, this is a digit too in my scheme. It's not really a digit, right? But I use the same event handler. So these are all operator clicked event handler. And I don't know if I can give you much more. These all are. I don't know if I can give you much more than that. You can see what the other events are, because I would have to open up one of these and just show you the code. And the thing is, just keep this in mind. This is I said dirty before. Dirty means like it's been changed. It's not clean. It's not okay to like save or whatever. That's what this means. This means actually, let me pause and look at it. I'm trying to remember exactly what I did with it. Okay, right. So yeah, it is literally needs clear. I was trying to remember why I used that. Needs clear describes what it does, because notice 3.2, I'm not clearing, right? I'm not clearing out this text box every time I click one of these. So what I'm saying, when it starts off as true, which means that I need to clear this 0 out and put in a 9, for instance. But now that I've done that, I set the needs clear to false. Now it doesn't need to be cleared as long as I keep clicking these kinds of buttons, decimal, point, whatever. That's all fine. But when I click an operator button, one of the things that happens is this gets turned back. This gets turned back to true, because I do need to clear out the whole text thing and then start doing new digits for the second operand. That's how the needs clear works. And again, real quick, I think what I'm going to do is I'm going to put up this video as is, and you guys can watch it. I'm going to try to strongly suggest you watch it. And if you have questions, I might have forgot to explain something in here that I could explain without just giving it away, right? So ask questions, send me email. Actually, be even better. Maybe I'll make a Lab 3 topic in the discussion forum. You can ask questions there. Don't share any code there, but you can ask questions, and I can share what I'm comfortable sharing about how all this works. And again, this is my way of doing it. If you do something that works, as long as it uses a calculator class and doesn't pack any of the cosmetic stuff into it, like for instance, the calculator class shouldn't have a needs clear method or something. That should be in the form, because it's more about how the calculator's job is to calculate. That's it. It's all about finding out what the operation is, what the operands are, combining them together with an operation and getting a result. That's all the calculator's job is. I did have one other thing I just remember I need to tell you, but so I'm gonna put this up. I'm gonna ask for questions. What was I gonna show you? Well, there's one thing for sure. Don't forget this: 9 divided by 0. So you could put whatever you want to here. If you want to be more classic about it, you could put like a -e- or something, or I'm trying to remember exactly what the error, or you could put error, right? But I put the literal message for what it was. You cannot divide by 0 in mathematics. So 9 divided by 0, anything divided by 0, 63. Divided by 0, it's going to give you attempted to divide by 0, which is an error. But you should also, so that's in a try catch, and the lab specifies that you need to do it that way. So it says somewhere here it is. If the user tries to divide a number by 0, the calculator should display an error message in the text box. The form class should use a try catch statement to catch the divide by 0 exception. So yeah, whenever you in your calculator class, if you get a 0 for the bottom operand, operand 2. So the one that's on the bottom, the one you're using to divide into with, if it's 0, you should just throw divide by 0 exception. So check the book for how to do that. I think there's an example somewhere, but you throw the exception. That's all you need to do. And then the try catch should catch that and notice this divide by 0 and do that some kind of message in there. You can do overflow if you want. I haven't made it overflow because decimals are really huge. I don't know what the limit is. I guess I could just keep holding down 9, keep pressing 9 until I run out of room or something, and then add a bunch of 9s again, see how big but I do catch overflow. I catch format exception though, because here's one of the cool things is because you're entering things through this, you're automatically restricting what can be the string, right? So it's unlikely that you'll get something that will cause a format exception, but I still do it just in case. And I catch exception overall. So any exception will appear here when I'm entering things in and adding and subtracting, and that's all in the form. You can't see it because I didn't show it to you. I think I do all that in the operator clicked. Let me pause and look. Yeah, so it kind of makes sense. It's in the operator click. There's a big try catch in here. I will tell you this too, there is a finally. So a finally is something that happens no matter what else happens. And keep in mind that when you click on the operator, you should always be ready to clear out the screen when you start typing new numbers for the second operand or subsequent operands, right? So that's what's in my finally. That needs clear equals true. Gets true. I think that about covers it. If I did forget something, maybe I'll just make a little post about it, because this is a very long, it's 40 minutes. I think that's worth watching all of it though, to help get some hints and get some questions. Don't forget about office hours. So you can always come to those if you have questions about the lab, but I'm going to give you more. It was due Monday evening. I'm going to extend it by at least a few days. I'll let you know in an announcement, but I'm going to put this video up first so you guys can start working on it. And I don't know about this weekend. If I have time, I can crank out, what do you call it? Chapter 13 video lectures. But if nothing, I think most of you would be more happy with this than you would be with lectures about that. But about 13. So make sure you look again at the structure here. You don't have to do it exactly like I have it. If you've already got it done and it works, don't worry about it. Make sure you do some testing and stuff in case you miss some things. I like have to do the thing with the decimal point now, but you should only have one. So that's another. You could just off the top of my head, I don't know how I'll actually do it when I do it, but you could have another flag, right? That's like it counts how many decimal points you've entered, and if it's above, if you try to do it and it's already 1, right, it's not going to let you. Then you reset it back to 0 after you do the operation, right? And then so it can always only be 0 or 1, or true or false. 1 exists, maybe it could be another flag, but that you would add to your form class. But whatever. I could see a rationale for actually having it also in the calculator, but we'll let the front end of the form weed it out first, I think. All right. Again, post questions, preferably on the discussion board, but you can also send me email.